In 4.1, just previously, we learned about what radian measures are and how they relate to degree measures. Now, we took a look at some of the really basic ones, but now we're going to talk about how we can convert from radian measure of an angle to degree measure. So we're going to, in this particular example, we're going to convert from degrees to radians, and so we're going that direction. Now in the next example, we'll go the opposite direction and make sure that you know how to do both. So converting from degrees to radians, remember that there's 360 degrees in a circle, 2 pi radians in a circle, so that's the entire thing is 360 and 2 pi. Those are the same as each other. Now what we're going to do is we are going to, in order to convert these, we're going to multiply by this fraction that you see right here, pi over 180. Now, why would we multiply by that fraction? Well, a couple of reasons. First of all, notice that pi and 180, those are the same thing. And so we want to introduce pi in here to make sure that we're looking at radians. And you might be looking at this saying, well, pi is 3.14, 180 is 180, so how are those the same thing? Well, it's based on the interpretation. It's based on the context. And so think about pi as being like 180. And so if we have 180 over 180, this is essentially equal to 1. So if we multiply by pi over 180 for any of these problems, we're not really changing the value of the problem, because whenever you multiply by 1, the same thing comes out. So we're just going to do that for each one of these. We got 150 times pi over 180. Well, like any fraction, we're going to combine these things together. We get the fraction 150 pi over 180. Once you do that, then you're just going to reduce the numbers as far as possible so that the end result, they're all integer numbers. And so we can divide each one of these by 30, giving us 5 pi over 6. And so that's going to be our simplified version of that one. Now the second one, as you'll notice, isn't quite as nice. The second one says 11.83 degrees. When you see something where it indicates a decimal right off the bat, they're just going to be looking for an approximation here anyway. So in this case, we're still going to multiply by pi over 180, but let's just work with numbers that are approximate at this point. So that means 11.83 pi over 180 if we put them together. And then we're just going to let the calculator do the work on this one. We're going to say, okay, well, divide those. It ends up being 0.21. Now you'll notice that that doesn't have any pi's in it. The pi was calculated in here, but this is still in radians. And so when you don't have a pi coming out, I would suggest that you just write radians afterwards, just to emphasize that it's radians and not degrees. Now this last one, that one will be a little bit nicer to work with, and so we're going to first of all take a look at, notice it's 75 and 30 minutes. What that means, we talked about this earlier on, was that this is going to be 75.5 degrees. And then we're going to multiply this by pi over 180. All right, so we do that, we get 75.5 pi over 180. Now this one's a little weird because we're going to reduce this fraction to whole numbers, but it's going to seem like it's not really reducing because we're going up. We got to get it whole numbers, and so we actually have to multiply top and bottom numbers by 2 to get them to be whole numbers. So 75.5 times 2 is 151, and we'll leave the pi. And then 180 times 2 is 360. So we've got 151 pi over 360. Now that's really not a very typical angle that we'll see, so don't worry about that one too much. It's just what happens to come out at the end of this one. Number 1 is our most typical example when we're talking converting from degrees to radians.